Hello and welcome to tonight's edition of Cracking the Cryptic. And look at this, we've got Fog of War to have a go at today, and a puzzle, actually one of the most recommended fog puzzles in existence. We do get a lot of suggestions to try particular puzzles, but this one by SamuPiano called 𝗟𝗃𝗲 expedition has an extra A in it to create a P sound, I think. Has had lots of recommendations. Apparently this is quite a difficult puzzle, and I did read the rules. It has got quite lengthy rules, and I imagine it's going to be quite easy to forget some of the rules, because all of the things in the puzzle seem to do a variety of different things, but apparently it's a wonderful idea. And someone on Logic Masters said you will never expect what's underneath the fog, so like the Spanish Inquisition, which nobody expects. We will have to have a look at this in a moment or two's time, and I will read those rules together and try and understand them. Before we do that, I don't have much news for you today, so I will make an appeal that's we make occasionally, and that is, if you do enjoy the channel, the statistics tell us that many people watch regularly who are not subscribed, and if you could subscribe, it would be most appreciated. It is totally free to subscribe to a YouTube channel, of course, and it just tries to teach that puzzle we have never quite cracked, the YouTube algorithm, how many people are really interested in this wonderful hobby that we all share, where we look at these fantastic puzzles every day. So maybe consider that if you wouldn't mind. And yeah, you can even join us on Patreon if you really like us. It's a couple of bucks a month to join us there, and there's lots of extra content. But why don't we just kick straight into it and have a look at 𝗟𝗃𝗲 by SamuPiano. 4 stars out of 5 for difficulty. Let's read the rules together. We've got normal Sudoku rules apply, which means we're going to have to put the digits 1 to 9 once each in every row, every column, and every 3 by 3 box. Fog. The grid is partially covered in fog. Placing correct digits will clear fog from surrounding cells. So I think that's old school fog. So there's a variety of fog. Well, there's 2 varieties of fog puzzles. There are fog puzzles where if you get this cell, for example, it will clear the fog from those cells. And there's fog puzzles where if you get this cell, it might clear the fog from down there. You just don't know. It's so-called dynamic fog. I think this is the former, I think. And then we've got cave. So it says, shade some cells such that all unshaded cells form a single orthogonally connected region, and all shaded cells are connected to the edge of the grid. So it's going to be hard to do an example of that, but basically there's going to be a region that's sometimes called the cave, which sort of, actually maybe I could do an example. Yeah, I mean that might be the cave. I don't think there's a 2 by 2 restriction in cave normally, so I think it could be this. And you can see that every cell that's not a green cell, that's not in the cave, does connect to the edge of the grid. So even that one, it sort of follows that path and it can get to the edge of the grid. So I think that's an example of a possible cave. Now, digits in circles either give the size of the shaded region in which it lies, or the total number of unshaded cells that can be seen in all directions from the unshaded circled cell, including the cell itself. Shaded cells block vision. I mean, this is crazy. So these circles, it's going to their quality, if you like, the rule that applies to them is going to depend on whether they are shaded or unshaded. And once we've made up our minds, let's say that this was unshaded, which means it's part of the cave, then the count in this cell will say how many unshaded cells we see in those 2 directions, and possibly that one as well. So let's make all of those wall, Oh, I've made this too big. that's going to be bigger than 9, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So if it was this, that would be a 9, I think. Now, if on the other hand, we say that this is a shaded cell, then I think the digit is going to depend. So this is going to be part of a shaded area connected to the edge of the grid, and that would be a 6 in that example, I think. Line count. Some circled cells are endpoints of lines in the grid. Oh, well, these two are. They've definitely got a line going out of them. Oh, I see. Okay, so I assumed these were circled cells because they were circles. They are circled cells, but these have an additional rule attaching to them because they've also got lines coming out of them. Some circled cells are endpoints of lines in the grid. All lines move orthogonally. Orthogonally means, let's go to the pen tool. If you want a pen tool, by the way, you just click on the cog icon and enable your pen tool. I always have my pen tool and my letter tool enabled, and that will bring up an icon on your on the right hand side of your grid, which looks like a sort of square with a circle with some lines in it, and that will allow you to sort of drag and drop these lines in the grid. Now, an orthogonal movement is like that. It crosses a big edge. This is a diagonal movement, and we're being told that the line does not do that. It never goes diagonally, it only goes orthogonally. Lines do not cross or branch except at circled cells, and the digit in a circle gives the total number of cells along each line attached to the circle of the same shading as the circled cell, including the endpoints. Oh my goodness. So we're going to have to... The digit in a circle gives the total number of cells along the line that have the same shading. So, I mean, we're going to have to work that out. And then we've got split p's as well. So digits along a line strictly between two circles. Let's put some circles in the grid and join them up. Digits along a line strictly between two circles must sum to a 2-digit number, where the tens digit is in one circle and the ones digit is in the other. So if this was a 1 and this was an... I tried to type 8 and failed, but let's say that was 1 and that was 7. Then digits along the line strictly between, yeah, so it doesn't include the circles themselves. Those 3 digits there would either sum to 17 or to 71, and I know which of those is more likely. So that's how that could work. And there's only one more rule. Digits separated by an x sum to 10, digits separated by a v sum to 5, and not all x or v are given. So we can't really see that, but say they were joined by an x, they would sum to 10. If they were 1 and 9 and they weren't joined by an x, that's absolutely fine. We're just being told positive information about some dominoes, and we can't even see any that applies to at the moment. So it's quite a difficult rule set, but do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. I mean, I'm going to try and join, or at least draw those in. Yeah, I mean, oh, actually, that might be wrong. Hang on, I was going to say these must join, but I had another thought. Could you do that? Or, more to the point, that could go off a wandering. Okay, so we need to think this through. So, I mean, that's true. And the only way that this cell here doesn't continue and close the circles is if that is a circle. I've got no idea whether that's possible. I don't think that's possible, actually. because I think we'd then have to decide what numbers we were putting in these circles. And one of the things the circles are doing is counting how many cells along the line are the same shading as themselves. Now this is a 2-cell line, so the only way that you can't put 2 and 0 in here. So the only valid shading would be one of each, and then they both be 1s, and that breaks Sudoku. So, okay, so we can rule that out, and we can join those up. And now these cells have to add up to 4. Is that right? It's not 2, is it? It's 4. I'm just going to double check that. Some circled cells, all lines move orthogonally. The digit in a circle. Oh, hang on. Yeah, okay, so I had slightly misunderstood this, I think. Right. These cells I'm going to claim are different shading, because if they were the same shading, say these were both unshaded, then we'd be counting how many unshaded cells there were on this line, but we put that same digit into both circles, which is going to break the puzzle by Sudoku. So one of these is shaded, one of these is unshaded, which means that the total length of the line is the sum of the circles. So I think they're a 1-3 pair then. They have to add up to 4, because they must incorporate the entirety of the line. And one of them is shaded. And one of them is unshaded. But the thing is that whichever way round that is, it means different things. So if... Oh, I'm sorry. Oh, hang on. Okay, I've got one point that I can think of that results from that. The 1 is not part of the cave. So it's not unshaded. Because if the 1 was unshaded, it's saying it can only see 1 cell. And that would imply the entire rest of the grid. Well, let's just think that through. So let's make that unshaded. Let's make this shaded, and let's say that this was a 1. Well, then all 3 of those are shaded. Yet, so this is the only cell in the cave. Oh, and that wouldn't work, because that would require this to be an 80, because there would be 1 unit of the entire rest of the grid would have to be purple. Because if say this cell was green, it couldn't connect. And that's obviously the same if this is the green one instead. It's very easy to make a logical error here. But I think I'm now sure. Actually, I'm going to say something else while it occurs to me. Because that example has made me remember something about cave puzzles. In a cave puzzle, you cannot have a checkerboard pattern. This is impossible. Why? Well, it's because we know that the cave is a single orthogonally connected area, which means that this cell has to connect to this cell in some way. And we don't know how it's going to do that, but it's going to have to do it. But the other requirement in cave, of course, is that this cell gets to the edge. All the bits of the wall have to get to the edge, and you can't do that. Because in connecting these two together, you are going to sort of create a wall of green through which the purple cannot get to the wall in one direction or the other. So, I don't actually... Is that so? As if there was a conclusion I could draw from that. I don't think there is. I think that's just a point that we're going to have to bear in mind. Hang on. These two cells have to sum up to 13. They can't sum to 31. Okay, so they're either 4, 9, 5, 8 or 6, 7. That's an appalling pencil mark. I'm not making it, but they add up to 13. Okay, and what did we work out? The one of these that's a 3 is the part of the cave, is the green clue. And the one that's a 1 is a wall clue that's on its own. So let's think that through. So if that's a wall clue and it's on its own, it's surrounded by green. So those would be green because there would be 3 cells of this line that are green. Now these would be purple because of this would be a 3 cave clue and it would see 3, so those would be purple, that would be purple, that green would have to get out, and that, well, if I'm meant to be able to spot that that is not possible, I don't know how I'm meant to spot that. That looks entirely possible. So the other way round would be purple here and this was green, and these would both be green. This would be a 3 and this would be a 1. Let's just put that in so we can, whoops. So these would both be green. That would be green, that would be green. Ah, okay. This version doesn't work. But it's tricky to see this actually, because what you have to do to see that this fails is that this is a 1, so it's the only part of its wall that exists. So these are both green. Oh. And now use the checkerboard argument. You can immediately see that this cell is green. Because again, if it was wall, this wall has to get to the edge. And in wherever it gets to the edge, it's going to divide this green from this green. And that cannot be true. The green is one area. So this is definitely green. And now I've got this supposed 3 clue. It's meant to see 3 greens, sees 4 greens, and actually it will see a 5th here. So it's the other way round. This is hard. Okay, so that means this is 1, I think, is the first thing we can put in. Yes, this is 3. Yes. Now this is it's green, isn't it? This is purple. This is green. This is green. That green clue is completed. It sees 3 greens vertically, so it must be blocked off by purplage. This is purple to avoid a checkerboard. This green has to get out, so it has to go there. Is that a V or an X? Oh no, that's a V, I think. Is that... I'm not so sure I know what that is. Bother. Okay, but this... Okay, there's a line that is definitely going into this square. So we know that those 2 cells... we know these have different shading. So that means the sum of these 2 circles will equal the length of the line, which is 1, 2, 3, 4, 5, 6. Right, so these add up to 6. This one can't be 1 or 3, so that's 2, 4 or 5. And this one is the friend of 2, 4 and 5, so it's 1, 2 or 4, such that these add up to 6. Now, is that a V? I think it is. So that is also 2, 4, or 2 or 4 actually. 2 or 4. I think that's reasonable, isn't it? I think that is a V. It's not an X. Oh dear. Okay, so what does this mean? So if I knew that that was a V clue, then this couldn't be a 2, because that would be a 3 and it would clash. Oh, hang on. Right, this is a 4 actually, Because remember, one of the jobs that the circles performs is it counts the size of the wall segment that this is a part of. And this already is part of a 3 wall segment, so it can't be a 1 or a 2. That's got to be a 4. Ah, okay, so this was a V, so it's a 1 beneath it. This must be a 2, because it's the letter. So this is a 4, this is a 1. Okay, we're actually getting this done. I couldn't be more surprised, frankly, because I'm not sure I understand it. Right, this digit, okay, I can see the difference now. That's definitely an X clue, isn't it? That was very different to what we saw here. So this digit is 6, 7, 8 or 9. It can't be, in fact it's not 8, because this can't, oh, it's not 6 either, because this can't be 2 or 4. So this is 1, oh, this is done, sorry, it's done. 3, 7. Now, this domino is a 5, 8 pair, because remember it added up to 13. So this is a 6, 9 pair. And now all we have to do, well, it's probably not all we have to do, but what we've got to do is to make sure that this line either adds up to 42 or 24. Probably 24, I would think. And it's the digits in the middle, isn't it? Yeah, so it's only 4 cells that we're adding up, so it's definitely 24. And these add up to 11. So these add up to 13. So this is 4 or 7. It's not 4. It's not 4. It's not 4. So that must be 7, I think. Oh, that is not clearing fog, but it could be because the fog was already cleared around that cell. I haven't made a mathematical error there. 13 and 11 is 24. I don't think I have. This is just a circle on its own. That doesn't have any line going through it. So that doesn't obey the obviously it doesn't have any of the total number of cells along a line. This cell, it's going to, oh, this one's just going to depend what shading it is then. Ah, hang on. This one is part of a shading of size 4. Which either, so this has to grow. I don't know which way it grows. It must be either one of these 4 cells is purple, and the other 3 are all going to be green. Oh, I see. Yeah, okay, gosh, the problem is here. These rules do a lot of things. Right, this clue is not only telling us that it's part of a size 4 slug of wall, it's also counting the number of purple cells on this line, isn't it? So that's purple, and that's beautiful, because now this must be entirely surrounded by green to make sure that's a size 4 wall piece. Avoid checkerboard, avoid checkerboard, avoid checkerboard, boom! Avoid 2 by 2. No, I don't think there is that rule. I don't think. So if this was green, it would already see 5 cells horizontally from a cave perspective. If it was purple, it would have to get to the wall. I see. Right. Look at this one. That's a 3. It's counting. You see this line here? We don't know where the line goes, but we do know it goes here. But we know it's only got 3 greens on it. 1, 2, 3. So both of those must be purple. Now avoid a checkerboard. That's got to be purple. Oh, wait a moment. Have I made a mistake? No, oh goodness, I thought I made an error there. Because I thought that this was meant to count the size of its piece, and obviously it's attached to an enormous piece, but no, that's a cave cell. That's in the cave. So this, right, so this is counting how many cells it sees. 1, 2, 3. So that's purple. Void of checkerboard, that's purple. This is at least a size 5 piece. So if it does join there, it would have to get to the boundary quite quickly. 2, 3, 4, 5, 6, 7, 8 would be the best it could do. But it could go 9 like that. Oh no, it could, hang on, it could go 9 there as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. It could do that, and then the green would come out across the top. So... Right, now I'm stuck. Now I'm stuck. 3 is down here. I don't think that this. I'm sort of even reluctant to do this. Actually, I can't, because it's not going to do anything, is it? The great thing about fog puzzles is they direct your attention basically to where you can see things happening. There is no way I know which of those is a 1. Maverick's flying over. What do I know about this? Yeah. Yes, that's it. Right, this 2 clue. That is a cave clue. It sees 2, so that's purple. So now if that was purple, that would be purple to avoid a checkerboard. 1, 2, 3, 4, 5, 6, 7, 8, 9. It can't be a 9 actually, because of that. So if this is purple, this is green. Now let's just go through all of the circles and check they work. That's a purple 1, that makes sense. That's a purple 4, that makes sense. That's a green 3, that makes sense. Green 2, green 3, don't know the colour. If it's green, it's at least a 5. If it's purple, we haven't got a clue. And this one, we don't know where its circle is. I suppose we know it's not that one, because that's not got any lines coming from it. And do we know the colour of its circle? Like, do we know it has to... Yeah, yes, we do. We do. We do know the colour of this one's circle, because if it was green, this count would be wrong. So imagine that this goes here, and that's a green cell. Well, then there are 4 green cells on the line, aren't there? Not 3. So that's not going to be right. So the other circle attaching to this is a purple circle. It's a purple circle, and therefore it does a few things, doesn't it? Firstly, hang on. A purple circle counts the size of the purple wall piece that you're a part of. It's also supposed to count the amount of purple on the line. So that can't be a purple circle, actually. I'm going to claim. I might be wrong about that, but I think that's right, because if this is a circle, it's a 2, because it's counting those 2 cells on the line. Yet that is a W pentomino of size 5. So this should be a 5. Because, in fact, it would have to be more than 5, because this would have to get to the edge. So hang on. Hang on. How does that work? So wherever I extend this line too, if that's going to be purple, I'm a bit worried I've misunderstood this actually. I'm going to have where what, okay, is what I'm about to say true? It might not be, so I'm going to say it and then we can discuss it together. It is true. Yeah, it is true, I think. What I was going to say is wherever this line goes, so it's going to go somewhere in the grid, but all of the cells it goes through to get to its circle are going to be purple, because it can't have any more green on the line. So say it went there. Obviously this is purple, and this is purple. But that's a problem. That is a massive problem. Because let me just show you why that's a problem. This count is trying to do two things simultaneously. First thing it's trying to do is to count how many purples are on the line. But the second thing it's meant to be saying is how many purples is the wall segment of which it is a part. And how are those two things ever going to equate, is my question. How? The only way they're going to equate with each other, I'm now going to claim, is if the wall segment of which this W pentomino is a part is entirely built of the line. Because imagine it wasn't. You just can't equalize the counts. Because what you're trying to do is to say every single cell of this piece is going to be included in the circle wherever it is. And yet the line count is also meant to reflect the same number, basically. It is meant to reflect the same number. If this goes off a wandering over here, then these cells are contributing to this count, but they're not contributing to the line. It cannot be true. It cannot be true. So the line, I don't really know how to do this because I don't know where the circle is, but this line is going there, there, and there. Yeah, okay, which means it's going there, I think. Because if it didn't go there, this would be green. And this line has to get to that cell somehow. There's no way it can get there without circling green. So that's definitely purple. And probably the line does that. But I'm not saying it does do that. I'm just saying probably it does that. Yeah, okay, let's just think that through. Let's say it did do that. Actually, it can't even... Now I've got another problem now. Because even though I think it could do that, I don't think... Oh, wait a minute. Hang on, I can see the... This is getting even more nuts. I've almost got this now, I think. Right, because... How does it... Okay, here's the other problem. How does the purple get to the edge? Because the line isn't going there. So having got to this cell... Actually, I'm now not sure. I'm just going to go back again. We have to get the line to there. And in doing that, we have to make sure we take all of these cells onto the line as well. And having got here, I must get to the edge. And here's another point, I must get to the edge pretty quickly, because I've already spent 6 cells of time wiggling around the grid. And I can only, the circle that is going to be on the other end of this line cannot be bigger than a 9. So if I did go, if it went straight down here, straight over here, and then down, because it can't go there, I've then spent 7 cells, and I've got 2 cells left to get to the edge. So I'm either going to the edge there or to the edge there. And that, I think, might be what we have to do. But I'm not committed to that, but I just want to think about that. Because how do you ever get the line here? And this okay, here's another way of thinking about it. The line has to get there, but having got there, we know the line doesn't go there because there's no fog here. There's no line in this cell. And we know that can't be a circle, so that is a visiting point on the journey the circle is taking. So that we definitely go here. And we've got to get to the edge. So now I think it is forced. It is forced because it's not like I can go here. It's not like I can take those cells and then somehow go to the edge somewhere else. I've only got 9 cells to play with. So I'm going to have to do it with efficiency. And it's either doing that or it's doing that, which means I think one of those is a 9. And unfortunately, the 9 we've actually got doesn't tell us which of those things is true, I don't think. There might be other ways to think about that, though. I really like that, though. That's very, very interesting that you can effectively work out that this is all parts. I know what we do. Because this either closes here or here, all of these cells are green. Because they must frame this 9-cell region, whatever this ends up looking like. In fact, that's got to be green as well by the same logic. So that's green to avoid a checkerboard, that's green to avoid a checkerboard. Now, what does that mean? I mean, how... So this line, it can't be a 93 line, can it? So it's going to be a 39 line. So, and it's going to be the internal pieces of this that add to 39. So it's going to be those 6 plus possibly those. Yeah, we can work that out. Okay, so if it goes straight down to a 9 here, then the line is going to do this. And we will know, because we can avail ourselves of the secret, can't we? The secret is something I share with only my very favourite people. Of course I'm sharing it with you if you're still with me 38 minutes into this video. The secret is that a complete column of a Sudoku, because it contains the digits 1 to 9 once each, sums to 45. That is the sum of the digits 1 to 9. Now, if this is a 9, 10, 16, 25, these would add up to 20. Right, this is so clever. Right, that doesn't work. Because these would add up to 20, and those digits cannot add up to less than 21. Because there are 6 of them in that box. And the minimum sum of 6 different digits is 21. 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. So 21 plus 20 is 41, which is bigger than the total this line can have. So I think we now know that the line goes there, and I think that is a 9. Yes. Oh, I think that's what it's showing, isn't it? Yes, it is. It is. It is. That's absolutely beautiful. Just, that's seriously beautiful logic. Now, well, now 9. Ooh. Okay, okay, I've done this rather glibly, but I'm now slightly worried. I've got a 9 on the line. By Sudoku. So I've got a minimum of 21 there. I've definitely got a 9 here. That's 30. And I've got 3 more cells to add in. It depends where the 9 is, but 3 more cells that can't add up. Well, that actually do add up to 9. Which... okay, so the minimum... Right, what's the minimum sum of those 3 cells? 915 is what I'm going to claim, which is 15. So 15 plus 21 is 36. So this digit is it's 1, 2, or 3. It's not 1, so it's 2 or 3. And unfortunately, I don't think I know which. But do I need a 1 on here? I think I do. I think if this wasn't a 1, the minimum sum of this would be astronomical, because it would be a minimum of 9 plus 5 plus 6, which is already 20 plus 21, it breaks. So this is definitely a 1. Yes. Oh, now that's a 2-3 pair, because that already sees a 1 in its column. Okay, so we can get rid of the 1s from here. We can get rid of the 9 from here. There's another line here that we're going to have to think about. I've got a 2-3 pair in row 7. What about column 1? I need 2, 6, 7, I think, into those squares. And I know that's not 7. One of these is 9. So, yeah, 8 can't be on here, can it? Again, that's going to take us up too high. 18 and 21 is 39, and we haven't included this digit yet. So this is either, it's 9-5 or 9-6. 15, 26, yeah, that's exactly what it is. And then we wish we knew what this was. But also, this collection of digits has to be very close to its bare minimum. Although we know so little about what's going on. Hang on. All of these are purple, aren't they? So all of these are green. Oh, this is big. This is big. Right, what's that done? It's so easy to forget some aspect of this rule as well. So that 9 is just saying that's of size 9. This 3 is doing a cave clue. The 39 together are doing the sum of all these digits. I've got a green clue here, but I don't know where this line goes, do I? Oh, wait a minute. Well, hang on. That's definitely a cave clue. So it's definitely not a 3. It already sees 4. So that cell is 4, 5, or 8, I think. Okay, no, I'm wrong. Well, well, that cell definitely isn't the end of the line. Because if it was, this 4 clue can't be correct, because it's meant to be counting the number of green cells on the line. There would only be, well, that would have to actually be purple, so there'd only be 2. So it's got to go to there. I think it's got to grow more, because again, what would you put in this circle? I think well, actually, even if it was here, this circle, it can't be the same digit, so it can't be green, because it would be the same digit as the digit in row 8, column 2. So it would have to be purple, and then these two cells would add up to 5, and they'd either have to be 4, 1, which they can't be, or 2, 3, which they can't be. So this also is not the circle. Now, if the circle was here, it would have to stop because it couldn't go into this cell, because this line would branch. Now, that doesn't work. This is too big now. It can't be. Oh, in fact, it's got the same shading as the cell next to it, which it can't have. So so this goes here, goes there, goes there. That could be the circle, but we don't know that. Sorry, a lengthy interruption there. I had to. I forgot that I was meant to be going to go to school and collect people. I'm so useless. Anyway, I've had to go and do that. So I've come back now. It's a lot later, and I've now got to. Hang on. What were we doing? I was extending this line into this cell. And okay, I can't remember what that means actually. Let's just go back a bit further. Oh my goodness. So I was doing something. I was extending that line. Why was I doing that? Oh, I think I'm going backwards again. So I was extending that line. Is that to do with this? I can't remember. Oh, bobbins. I really should. What I do when I come back to the computer is I just sit down and start again. I should actually spend a moment just trying to resurrect my thoughts. Why did I extend this? So this is a green 4, 5, or 8. So I have to. Oh, I know. Right, hang on. But this is doing duty as a cave clue. So it already sees 4, so it's at least a 4. So, and it can't be 6 or 7, right? So it's 4, 5, or 8, can't be 9. And why then? So do I know what colour these are somehow? If that's a 4, this is purple, and the line contains 4 greens, of which I've put 3 onto the line. So I'd have to put another green onto the line. Oh, if that's 4, that would be purple as well. So if that's a 4, both of those would be purple. Hang on, where's 8 in column 3? Why? I've not got 8. Oh, I know why I haven't got 8 in there, because I have got 9. I remember that bit. Those had to add up to 39, didn't they? So we had to have quite a relatively low digit, being a 5 or a 6 with the 9 here. Right, 8 in this column is a very easy question. It's down there, so that is not 8. Now, can we do better than that? It's either 4. If it's 4, well, if it's not 4, the 4 is in this cell. It's 4 or 5. If it is 4, then it already sees its 4 greens. So that would be purple. That would be purple. There would be one more green on the line. But I don't think I'd know where that goes. Or would I? I'm not sure. Okay, let's think about it a different way. If it's 5, what does that mean? That means either this is green and this is purple, or this is green and that's purple. And in that situation, that would also be purple. Or, okay, hang on, maybe it's better to think about whether the line could end here. If the line ends here, it couldn't be green, because if it was green, it would have the same number in it as this, because it would be counting the number of greens on the line. So if it does end there, it's a purple. And hang on, let's put that in. So it's a purple, and it's a purple circle, and the line length would be 1, 2, 3, 4, 5, 6, 7, 8. And this would be, well, it couldn't be, this would have to be 5, because it couldn't be 4 and 4, could it? So this would be 5, this would be 3, this would be 5, this would be 3. So this would be green, and now this would be a 3, and it would have to be doing two things. Firstly, it's counting the size of its wall slug that gets it to the wall, to the edge. Secondly, it would be the number of purples on the line, and this would be green, so it couldn't be those two being purple, because then by checkerboard that would be purple, that would be 4, which this would be. So if this is the end, A, this is 5, B, this is green, C, that's purple, and then these would be one of each, and that would be a 3, so it would be part of a 3 area. So if that was green and that was the area, is that wrong or not? I don't know, actually. I'm not sure. Oh, okay. So let's try. Hang on. Let's try something else. Let's try this one. What is that one doing? And I'm sorry if I've probably done this before I got interrupted. If that's green, it's at least 6, and it can't be 9. So it'd be 6, 7, or 8. If it's purple by checkerboard, this is purple, and that's at least a 3. 3, 5, 6, 7, or 8. I dispute whether that thing is doing anything at all. I just don't think it is. Oh, for goodness sake. Right. Okay. Oh, for goodness sake. Right, I'm sorry. It's much easier than anything to do with this line. Those two cells are the same digit. Because obviously whatever that is not that, is it? Those, oh my goodness, this has been available for ages. Right, I don't know how long this has been available, but those two are the same. So they can't be 2. Because there would be no spaces for 2s in this box. That has to be 3. Okay. And that... Oh! Right. Well, hang on now. Hang on. Because we've now got the circle. Oh, wait a moment. That's not what I thought was going to happen at all. I didn't actually realise that could happen. But that appears to be green, which is the same as that. So that's got, these are the same digit. I mean, let's put that digit in, but also give it a little, in fact, I might give it a little shading, actually. I know. Those are the same. So the total for this line, which we now actually know what the line looks like, is 44 or 55. Which I think both of those might be possible, actually. I mean, there seems to be quite a lot of scope for enormous digits there. But, hang on, let's just think this through. So this cell is now counting. I'm just wondering if... no, that would be okay, maybe. Oh, maybe it's that. Hang on. Let's just check this. That is definitely an X. And it's not 3, 7. Hang on. We've got 39 here. I know what we do. I know. Yes, I know what we do. We don't do anything to do with... This line is impossible. We don't understand it. But we do... Once this is a 3, all of a sudden this 39 line is forced, I think. Because they are at least 15, aren't they? Which means those are at least 18, and those are at least 21 by triangular number logic. This is 1, 2, 3, 4, 5, 6 minimum. And that's what it has to be to get to 39 now. So this is not... This is 5, 9 is what it is. It doesn't give me this digit. 2... Oh, hang on. No, it does. It does. That's got to be a 6. Didn't clear fog. Rotten thing. These are 2, 8, I'm going to claim. Apparently not resolved. Although that's lovely. Oh, that's... No, this is beautiful. This is beautiful setting. I'll show you why in a second. Right, but this is 4 or 5, I think. Not 3. So we can get rid of the 4s from here. These two squares are now 6 and 8, I want to say. But what I want to do is this. Because look at this lovely, lovely pencil mark. This has to be 1, 9. Because it can't be 2, 8, it would kill this cell. It can't be 3, 7, and it can't be 4, 6. So that is a 1, 9 pair. But we also know, don't forget, that that is a 1, 2, 3, 4, 5, 6 quadruple to make this 39 possible. So that's 1. This is 9. These are a 7, 8 pair. Oh, this is just filling in now. Well, this is good in a way. It's good. So these are not 4. This one, this is another X that isn't 2, 8, 3, 7 or 4, 6. So this is another 1, 9. And this is 9 by Sudoku, and this is 5. There's another liney thing here that we probably need to think about at some stage. This digit is 2, 5 or 6 by Sudoku. Oh no, I really don't want to think about this line. This line looks complicated. If that's a 4, then that's purple, and that's purple, and that would be a 4, and that would have to be green, and that would have to be purple. If it's 5, though, who knows, basically. If it's 5, that's 4. We do... Oh, actually, hang on. Those cells, which I noted could be high, are now very likely to be enormous. No. I've definitely got 7, 8 and 9 down here. So that could even be 24, couldn't it? Hang on. If that's 55... and that's 24. That's okay. It's straightforward. I think I might have got my maths wrong, but I'm going to double check it. So the maximum sum of those 3 cells is 24, and we've got 4 more cells here, which could have added up to 30, but can't here because none of them is a 9. So actually, the maximum there is going to be 13 and 9, which is 22. So 22 and 24. Is 46. It is not 55, is it? So these have to be 4s, I'm going to claim. Yes. So that's a 5 by Sudoku. And that 4 is completed in terms of the cave clueiness. Those are both purple. That's green to make sure this sees 4. That's purple. It's weird. So this line... 1? No, okay, no, it's still good. It's still good because this line now has got 1, 2, 3, 4 greens on it, and that's all it's meant to have. So everything else on this line is purple. This is purple to avoid a checkerboard. If that's purple, 2, 3, 4, 5, 6, that would be it. No, that's it. This has to be green because if it was purple, it's part of a region that's at least 7. And it sees 7, 8 and 9. That's rather beautiful. Oh, but now... Oh, no. It's okay. this is really good. Right, this from a cave perspective now sees 6. So that's all it could see, because 7, 8, and 9 can't go into this cell. So that's 6. All of this is now purple to avoid that 6 getting too big. That's purple to avoid a checkerboard. That's purple to avoid a checkerboard. There can be no circles in this region because it's already bigger than size 9. Now, I'm not sure what... Oh, that 6 is doing some work. So that's 6, that's 8. These don't include 8 anymore. And, okay, is it this? Well, that digit is an interesting digit, because it's got to be a low number. It sees 6, 7, 8, and 9. It sees 2 and 4, so it's 1 or 3. And this digit is 7 or 9. And alas, I think both of those things are possible. Oh dear. Right. It's a bit odd, actually. So this one, obviously, it's going to there. But we don't, or at least I don't think we know what colours these are, or anything really, do we? I mean, this feels like the most unrestricted digit ever. Right, those are not 2. This is not a 4. That's 2, 5, 6. So that is 4. Didn't clear fog. Bobbins. 4 is in one of 2 places in box 2. This digit... I mean, if that's purple now, because this would be purple to avoid a checkerboard, this would be at least a 5. And if it's green, it's at least a 6. If it's green, it is 6 or 7, depending on whether this is green. And I think that's all that circle's doing, isn't it? Because it hasn't got a line coming from it. So we wouldn't need to know more than that. Oh, where's 1 in box 8? That's a very easy question. It's there. Oh, I hope that's right. Okay, so these are probably joining together. 9 is now not in those cells. Now, I wonder if we can actually prove that these do join together. Ah, I tell you something. Oh, I've got it. Oh, this is lovely. It's lovely and it's simple, which is a relief, because this can't be purple. We just said a few moments ago that you can't have a massive purple region because you can't put like a 20 into this cell. So that's green, but not only is it green, look, it's got to connect to its friends. So all of those are green. Now, what does that mean? It means this digit is quite a large old digit. Because, oh no, or does it? Hang on. That's not true. That's total and utter nonsense. It means that's a 2 by cave rules. Sorry, I didn't... that's just appalling. But now that is a 7-9 pair by Sudoku. So hang on, what have I not put in this? 3, 5, 8. That's a 5, naked single. So this should be a 3, 8 pair, which we can do as well. Okay, so 3, 8, 4 in the corner. 1, 3, 5 into those cells. So these should be 6, 6, 7, 8. And this is 2. So if that was green, it would be a 2. And... well, I'm assuming actually there that these build up. Oh, well, that, hang on. I need to, I can't actually see. I need to see where, well, this, I'll tell you something, this can't be a circle. Because again, it would be a purple circle in an enormous region. Now, I think that doesn't seem to be in the fog. But this one is. So I'm just wondering whether it could turn, this line could turn here and continue up there, and then this could turn up there, and these wouldn't meet here. I really, I don't know. How are we going to tell that? I am not sure. It's probably going to be some facet of the rules that I've forgotten, isn't it? That's almost certainly it. Ah, that's a 9, and that's a 1. So this isn't a 1. 9 is in one of those two cells. Now, if that was 9, we would need to know how it was shaded to know anything about it, I think. Hang on now. Well, now it's not possible for these two to go. They can't both go wandering very far, can they? That's going to be it. Yeah, that's going to be it. Right, so we know that this is not a circle. So this could turn here, that is possible, and then go here. If this could be a 2 then. But actually it would be the wrong count anyway, because there would be 3 green cells on the line. So it can't do that. That's just not going to work. So I think this has to connect up. I mean, the other way I was seeing that is that this can't be a circle, because then these should add up to 3, and they can't. And this can't be a circle, because these still would have to add up to 4, which they can't. So this is joining up, and this is either a 2, or it's purple, in which case maybe all bets are off. We just have to make sure this purple didn't meet that purple. If that, oh hang on, if that is a 2, then it sees it's 2, and all those would be purple, and that would be purple, and that would be purple. That would be incredibly forcing. I think that's what's going to happen, because I can see then that the green has to come up this column so far. So that's what I think's going to happen. So that happened when this was green. So why can't that be purple? If it's purple, these two digits add up to 6. So this would be a 4, and that breaks. Beautiful. Okay, it's straightforward. So that is green. It is 2. Now these squares have to all be purple. This has to be purple to avoid checkerboards. This green has to get out and attach to its friend. So this digit is definitely not a 1 now, because this is a cave clue. So that's the 1. That's the 1. And I think we might be getting somewhere now. This digit, 1, 2, 3, 4, is at least a 7. It's not a 7, so it's now at least an 8. It's probably a 9, actually, because 9 could go into this cell. And here's another thought. These 4 cells add up to 22. I mean, it's not a very good thought. Admittedly, it's not really a very brilliant thought, is it? But one of the digits is a 4. I'm going to claim by Sudoku. It's going to be something like, I'm not sure actually. So what are the options for these squares? 2, 4, 7, 8. Oh, sorry, well, this is a 2, so we can do more. 2, 8 here. This isn't 2, so this is 2. I hope this is clearing some fog somehow. This is not 2 anymore. So these digits are known. They're 4, 7, 8. And what do we say? 22 for this. So this is at least 11. So it's either 11 or 12. So this is either 11 or 10. Oh no, there's loads of options. That's very annoying. That's genuinely quite surprising, actually. Okay, where's 2 in column 9? There is the answer. That's going to clear some fog. So that's now, oh, that's weird. There's 2 of these together. So, hang on, this can't be purple, because these would contain the same number. They'd be part of the same wall unit. So that's got to be green. And now, it's 6 or 7. And unfortunately, I don't think we're any closer to knowing which one of those it is. Now, on the other hand, aha, that is now a 4. That's a 3. So this has to get to the edge. Well, it's very easy for it to do that. It means those 2 aren't both purple. In fact, no, it means something much simpler. That cannot be purple, because then by checkerboard, this would join up, and it would be a size 4. So that is green. And that tells us that this is 7. This is a very, very good puzzle. Now, 5, 6, 8 into these squares. And one of those is purple at least, maybe both. Because this has to get to the edge, and it can only be part of a size 3 region. That 7 is doing a little bit of work down at the bottom of the grid, so we should take advantage of that. 5, 6, 9 into this column. So this is 5 or 9. 5, 6, 9 here. And this column needs 5, 6, 8 on the other hand. And that's still not 6. So that's a 5, 8, 9 triple. And oh, I see, 4 in the row goes there. So 4 goes here. And we need... Sorry if this is all obvious to everybody. I don't mean to be obtuse. I'm trying my best. I could get a 3 in... I could actually get a 3 in the corner there. That is possible. And this is 8 or 9, and that's not completed yet. We've got to get either that's green, or both of those are green, or that's green. Oh, if that's green, that's definitely purple, because otherwise this clue would see too many greens that way and that way. And I've still got to make... Right, what have I got here? I've got 18 in those 3 cells. I can see immediately it could be 3, 7, 8. Oh, it's parity, is it? No. No, it is. Oh, that's beautiful. It's parity. It is parity. Okay, here is a lovely, lovely, lovely point. Although, no, it really does do things. This digit, okay, we've got to think about which one. This digit is one of those 3. But this is 3 or 5, which means these 2 digits here sum up to an odd number. Because we know that we're looking for 18 from these 3. Because this is odd, therefore, these sum to an odd number. So they can't be the same digit, because then they would be even. So this digit can't go there by Sudoku. It can't go there, because parity doesn't work. So it goes there, and that is a 7-8 pair, so that is a 9. So this is 5, this is 6, this is 5. This is 8, this is 6, this is 9. How is that not resolved? That's unbelievable. This corner digit now is 3 or 5. And how does that not resolve then? That's really weird. Okay, so if that's 5, then those 6, 7 works. And if that's 3, 7, 8 works. In either order, I think. But that's 5. So this is 5. And that's a 3, 6 pair. Aha! So that is 3 in the corner, I think. That's 3 in the corner. That's 3 in the spotlight, losing its religion. Okay, we need... What do we need? 5, 7, 8 along the top row. And somehow or other this must be resolved. Oh, the 9. Well, the 9 only sees 7 at the moment. It can't see both of those, so that's certainly green. And either the 3 is green. There can't be any more lines and things that I've not used. So somehow or other, this is now... That can't be purple. Because if it was purple, it would connect to the 3 to avoid a checkerboard, and then I'd have the most enormous purple area. So that's got to be green. Now this has to be purple to stop this seeing all of those. So that's green in the corner. And the same thing again. That can't be purple, or it would connect by checkerboard logic to there. So that's green. Now that has to be purple. That has to be purple. This is a 3, so we must stop it. And that's the shading done. Good grief. This is, I mean, it's still being clever at a point where it's got no right at all to be clever. That's a 3. So that's 3, and that's 5. How can that not resolve it? How? What? Come on. What? Which clues have I not used now? It can't be this, can it? Oh, yes, it can, because that's become 5. So I've got 9. I need 13, and that does do it. So that's 6. That's 7. That's 8. That's 7. That's 8, hopefully. So that's 8. I don't seem to be clearing any fog. I really hope that's just because I've got no fog to clear anymore. Okay, I think I've finished it. It's a brilliant puzzle. Let's just double click the greens is what I want to do, just to make sure it looks like a cave should look. I think it does. That looks lovely. Let's see. Yes. Wow. That is a sick puzzle, SamuPiano. I found that really... It's brilliant. I mean, there's a bit at the start where you have to work out that this... It was something to do with that this area here has to stay together and the line has to traverse it. That is breathtaking. Absolutely breathtaking. It's a brilliant puzzle, actually. To be honest, I really liked this bit as well, where I knew I could see those digits couldn't be the same digit. That was really clever as well. Not I hasten to add of me, but entirely of you. SamuPiano, 𝗟𝗃𝗲, very brilliant puzzle. Let me know in the comments how you got on with it. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.